Today is going to be a very short lesson, sort of building off of what you guys did yesterday on drawing hydrocarbons. So yesterday you guys were introduced to organic compounds. Organic compounds are just a fancy term for things with carbon and hydrogen. It's a special subsection of chemistry that only looks at compounds that contain hydrogen and carbon, excuse me. Now you can throw in some other elements like nitrogen, sulfur, oxygen, but mainly it's just looking at carbon and hydrogen. And there were three different types of hydrocarbons that you guys saw in the notes. One being an alkane, which is a atom or a molecule that's only made by single bonds. So if it ends in this ANE, it is an alkane and it only has single bonds. An alkene is a hydrocarbon that has one double bond between carbon atoms. So 2-butene, I'm going to go into a depth of what this 2 means, but you can tell it's an alkene, ENE, because it ends in ENE. And finally, an alkyne has a triple bond, so if it ends in this YNE, you know that there's a triple bond somewhere in the compound. So a lot of you guys are probably getting confused, like we already learned how to name ionic compounds, covalent compounds. This is a whole new system of naming that we're going to get into, and it only relates to hydrocarbons, things that are organic. So these, again, remember, are your homologous series of hydrocarbons. I'm going to talk about that a little bit later with table, Q. Table Q gives you your general formulas for the homologous series. All that means is if something's an alkane, an alkene, and an alkyne. So let's say that I wanted to draw these hydrocarbons, or if you get the name drawing, if I give you this picture, I want you to name it. There's different steps that you could do. Like you saw yesterday, table P is very useful because the prefix, or the part that comes before the actual name, tells you the carbon chain length. So if something has a prefix of but, you know it's going to have 4 carbons. If it has a prefix of prop, you know it's going to have 3 carbons. Very easy. For now, we're just going to keep it simple. Step 2, you want to use the correct name, right? If it's an alkane, you want to name it using the ANE ending. If it's an alkene, the ENE, and alkyne, the YNE. Now, if you have an alkene or an alkyne, you have to have a specific little part. So you have to have a specific step, excuse me. So that step is going to be to place a number before the name that relates to the location of the double or triple bond. All that means is if we number these carbons, let me number them from left to right, right? Let's say 1, 2, 3, 4, 5. There are 5 carbons if we name it from 1, 2, 3, 4, 5 from left to right. What if we number them the other way? Let me just change the color. And we say this is 1, 2, 3, 4, and 5. Well, if we're looking at the red numbers, see how that double bond is between the 2 and the 3 carbon? And if we count the blue numbers, it's between the 3 and the 4. So for naming purposes, there's a specific rule that we are going to have to use the lowest number carbon. So in this case, the lower number carbon is this 2, because when we count from left to right, the double bond starts on the 2 carbon. It doesn't start until the 3 carbon if we number from right to left. So if we were to name this, there are 1, 2, 3, 4, 5, excuse me, 5 carbons is pent, right? P-E-N-T. We have a double bond, which means it's going to end in E-N-E, so it's pentene. And the number we put in front will be 2, because that's the lowest number when we count from left to right or right to left, where the double bond begins. So the double bond begins on the 2 here, the 3 here, so we go with the 2 because it's the lower number. Remember that carbons can make 4 bonds. Double bonds count as 2, triple bonds count as 3. Why do they make 4 bonds? Because they only need 4 extra valence electrons to get that octet. So here, you can see we have 1, 2, 3, 4 bonds. If we were to count the bonds on this 2 carbon, right, there's 1 to the hydrogen, 1 to the carbon, and then 2 to this carbon. So for your purposes, carbon is never going to make more than 4 bonds total. That doesn't mean 4 lines. It just means, well, actually, yes, it does mean 4 lines. You can think of it like that. Carbon is always going to have 4 lines next to it. Again, if you have a double bond, counts as 2, triple as 3. So table Q and table P are going to be your friends in naming organic compounds, right? Table Q tells you if something's an alkane, or an alkyne. Table P tells you the prefixes, which relates to the number of carbon atoms. And I'll walk through some of these samples with you. So let's say we had to draw this, butane. Well, but, if we look at table P, tells us that there are 4 carbon atoms. So we can draw our 4 carbon atoms in a row. Are there any double or triple bonds? No, because it ends in ane. It's an alkane, not an alkene, and not an alkyne, which means there are only 4 single bonded carbons. What do we do with the rest? Well, we could just draw in lines like this, and that is acceptable. Those lines indicate, or almost like tell a chemist or tell a scientist, that there are hydrogens at the end of each line. If you want, you can go ahead in and draw the hydrogens. It's not necessary. So either the right half or the left half would be accepted. You'll see both. You'll see where they just put the stick and you have to assume that there's a hydrogen at the end, or you'll see the hydrogens written out. But this is your butane molecule, right? All single bonded carbons with hydrogens at the end, and there's 4 because table P told us that it is but, 4 carbons. What about ethene? Ethene, ETH, that prefix tells us there are 2 carbons, and the ENE tells us it's a alkene, which means there's a double bond. Well, since there's only 2 carbons, the double bond has to go between those 2 carbons. And again, each carbon is going to want to make 4 bonds. So we're going to fill in 2 more hydrogens for each of these. Again, drawing in the H's is fine. If you want to just leave it as blank lines, that's fine too. But this is ethene. Each carbon has 1, 2, 3, 4, 1, 2, 3, 4 bonds, and they are double bonded to each other because of that ending. This is where things get a little tricky. We have 2-butyne. First things first, start with the prefix. But tells you that there are 4 carbon atoms. 2, 3, 4. The YNE tells us that somewhere within these 4 carbon atoms there is a triple bond. How do we know where the triple bond is? That's where our handy dandy number comes into play. That's 2. So if we were to number these carbon atoms, 1, 2, 3, 4, it tells us that that double bond is going to start at the 2 carbon. So when we put in our double bond, we're going to put it starting at the 2 carbon, not the 1 carbon, right? We're actually going to put it, let me change that. Ooh, sorry about that. Let me change that arrow. Really, it should be going here, starting at the 2 carbon. What do we have to do? We have to make sure that each carbon has 4 bonds. This one only has 1 right now, so we'll draw in 3 more red lines. This one, if we count 1, 2, 3, well, I actually made a mistake. Why? This is an alkyne, not an alkene, so we have to draw a triple bond. Now this carbon's happy. 1, 2, 3, 4. 1, 2, 3, 4. This carbon's happy. We just need 3 extra hydrogens around this carbon. So this is 2-butyne. Has that triple bond that starts at the 2 carbon because of that 2. We know it's a triple bond because it's an alkyne, the YNE ending. Similarly, 2-heptene. That hept from table P tells us there are 6 carbons. 2, 3, 4, 5, 6. We know that there's a double bond somewhere because of that ENE ending. And where is it? It's going to start at the 2nd carbon. So again, if we count from left to right, this is our 2nd carbon. If we count from right to left, this is our second carbon. So I'm actually going to try to draw both versions. I'm putting that in quotes because they're really the same thing. But this, 1, 2, 3, this, is 2-heptene. And 2-heptene also could look like this. Carbon, 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 5, 6. These are the same exact thing. You can imagine just kind of like flipping this over. Oh, it's too close. Okay, well, you have to imagine that there's lines 1, 2, 3, extra hydrogens. But imagine just rotating this molecule like that. You would get this molecule. That double bond would now be here instead of here. So it's the same exact thing. Just make sure that you're using consistent numbering. So if we number from left to right here, this is our second carbon. We start the double bond right there. What if I asked you to go the other way? Well, if I give you C3H8 and I want you to name it, let's figure out what that is. This is where things get kind of complicated, but not really. We can look at the ratio of the carbons to the hydrogens. And for that, we're going to use table Q. So this is that thing where N in these formulas equals the number of carbon atoms. So let's say right here our carbon atoms are equal to 3. When we double 3, we get 6. So if this was an alkene, we would have 6 hydrogens. Do we have 6 hydrogens? No, we have 8. So how do we get from 6 to 8? You have to add 2. So since the number of hydrogens is 2 times the 2 plus the double of the number of carbons. We doubled the number of carbons added 2. That's what I wanted to say. It is an alkane. So what does that mean? Well, it's going to end in ANE. How do we know what the prefix is? Well, there's 3 carbons, which relates to prop. So this is a good old propane. If you have a grill at home, propane is the gas that you use to light your grill. Either propane or butane, sort of a mix of the two. This is just propane. Next, we have 1, 2, 3, 4, 5, 6 carbons. 6 carbons, if we go to table P, tells us it is hep. What is the ending going to be? Well, there's a double bond, so we know it's an alkene, so it's going to be heptene. We're missing one extra thing. Because it's an alkene, we have to add the number. So let's count from left to right. 1, 2, 3, 4, 5, 6. If we count from left to right, that double bond starts on the second carbon. If we count from right to left, 1, 2, 3, 4, it starts on the fourth. So we don't want to count that way. We want to count the way with the lowest number. So this is going to be 2-heptene. What about C? C is nice and easy because we have 1, 2, 3 carbons. 3 carbons relates to prop, as we know from the first one. Instead of being propane, though, this is going to be propene because there's that double bond. And this one's kind of special because we don't need to put a 1. We don't need to say 1 propene because if we number 1, 2, 3, starts on the first carbon here, but imagine if this double bond was moved over there instead. It would still be 1 propene. It would just look like this. Carbon, carbon, double bond, carbon. Same thing. It's just rotated 180 degrees. So this is just propene, not 1 propene. D, we have 1, 2, 3, 4. 4 is bute. How do we know what ending to do? Well, there's a triple bond, so it's butyne. This one, we have to include a number because there's more than 3 carbon atoms. That's sort of like the trick. If you have more than 3 carbon atoms, you have to say where that double or triple bond is. So here it's nice and easy because it's just on the first carbon, 1-butyne. And we definitely have more than 3 carbon atoms in E. We have 1, 2, 3, 4, 5, 6, 7, 8, which is oct. So think like an octagon, right? Oct is the prefix for 8. We know that there's a triple bond, so it's going to be octyne. And when we count from left to right, it's on the second carbon. When we count from right to left, 1, 2, 3, 4, 5, 6, it's not until the sixth carbon. So this is going to be 2-octyne because it's on the lower number carbon. So the main thing to do is get your prefix, right, using table P. Then figure out, is it an alkane? Is there an alkene? Is there an alkyne? Once you figure that out, if it's an alkene or an alkyne, you have to see if there is more than, I'm typing with a mouse right now, or drawing with a mouse, so it's a little hard, more than 3 carbons. I'll just do that. If so, put number. So you guys are going to give this a shot in a practice worksheet that is posted on iTunes U with this PowerPoint, with the link to the YouTube video. So if you guys need any help whatsoever, just reach out to me. I can do a Google Meet. I can do a Google Hangout. You can text me and remind. You can email me. Anything to help you guys out, but give this worksheet a shot. It's not too bad. All right. I will talk to you guys probably next week because I'll probably give you something easier to do on Friday. Have a great weekend.